Okay, so now that your tests are graded and you have them back, you're not necessarily done with them yet. I do allow you to redo the problems you got wrong and turn that back into me. So those of you here in Rice Lake, you can just redo them and give them back to me here. At the other campuses, it's up to you whether you want to redo them on paper and have them scanned and sent to me, or if you want to just send me an email and in that email say, okay, problem number 23, this is what I need to do. When you do your corrections, though, I do require you to show your work. So that's the only thing with those. And if you do that, I give you up to half your points back. So let's say your score on here is a 70. If you do your corrections and you get them all right, that brings you up to an 85%. Now, with that said, make sure you get them all right. I don't care if you work with other students, if you get outside help, or if you come to me. I'm more than happy to sit down with you and work through all of them together with you if I have to. Part of the point is I want you to have the correct answer and the correct process down before you move on. I'm going to give you a couple of weeks to do that, so there's no rush. Take some time to work on it on your own. I'm not going to answer any questions in class tonight because I do still have 2 students that need to take the test. So we're going to give them one more week to do that. But starting next week, if you guys do have any questions on the test, I will be happy to answer those. Take some time in class to answer those for you. So for tonight then, we're going to go ahead and get started on our new material. Unit 2 in this class involves 2 things. We spend 2 weeks on basic statistics and data organization. And then our last 2 weeks are on merchandising and invoicing. So these first 2 weeks are the statistics. I think this is one of the more important parts of the course. And the rest of the class is really just applications of formulas and percents. This part here is really where you start to understand numbers and what they mean and how they work. And statistics, we're not going to get it far enough into it in the couple of weeks we're going to spend on it here. But statistics is really how you effectively gather information and then use it to make decisions. If you look at any of you that are looking to go on for a bachelor's degree, pretty much every bachelor's degree out there requires a statistics course at some point in your degree. Also, if you look at most major corporations, people that are in management positions, they have 2 things in common. Most of them are from an accounting background, and nearly all of them have a background in statistics. So that's how major decisions are made based on numbers. This, I believe, is chapter 5, I think is pretty much where it all is. And the new textbook, it might be chapter 6, I'm not totally sure.
But over this next couple.
Yeah.
I think it's 7.
Is it 7 in the new book?
Yeah.
So the next test will be covering from this chapter to what chapter?
That's a good question. Here, I'll take a peek and I'll be able to pull up the chapters for you for this next test. Okay. Okay, so this homework starting out, this is chapter 7 tonight. So the statistics is chapter 7. Next week is still chapter 7. Chapter 8 then on discounts, and should be chapter 9. So 7, 8, and 9 it looks like for the next test. This textbook seems to change the way they number the chapters every time we have it published. So. It used to be actually the chapters were numbered 1, 2, 3, 4 on up through 12. And now they've got them so the numbers skip around. They're actually numbered after the original textbook.
What's that? The second the second part of this coming unit?
We're going to have 2 weeks of statistics. So this week and next week are statistics.
Yeah.
The third week then is going to be on invoicing, trade discounts, merchandising, cash discounts, credit periods, discount periods, stuff like that. And then the fourth week is going to be on markups. Okay, so statistics. We're going to start out, there's a lot of vocabulary involved. If you get deep into statistics, it's almost like learning a second language because there's a lot of unique words that are used and then a lot of other words that are common words that are used in a unique way. So we're going to start out, statistics is basically about gathering information. And the first concept you need to understand is the concept of a population. A population is a group of items that share a common characteristic. And for statistical purposes, it is the group that we want to learn about. Now that might be more difficult to define than what you might think. You have to be very careful about how you define the population. Now we just went through a presidential election, so this example is a little bit worn, but let's say you want to learn about there's a new city ordinance that's on the ballot to be voted on for the next election. And you're trying to learn, is it going to pass or not? Do you think it's going to pass? What we're trying to learn about there is not the ordinance itself, because the ordinance itself does not determine whether it passes. What we want to learn about there is the behavior of the voters. So our population, it would be easy to define the population as all the voters within that district, but that's not what our population is, because not all the voters are going to vote. What our population would be there is all of the people who will vote in the next. In that next election. Notice I didn't say registered voters or anything like that, because every election there are people who vote that probably aren't supposed to, and there are a lot of people who are able to vote that don't. So that's a very carefully defined population. Now it's possible in some cases to contact every person in that population. Now it doesn't have to be people, by the way. Our population could be items. It might be products if you're looking at quality control and manufacturing. It could be a lot of other things could be our population. It's just when we're talking about business, it's usually easiest to talk about people. But we could contact every person in that population. We could gather information from every item in that population. But in most cases, we don't for several reasons. What we do is we choose a sample. A sample is a smaller group chosen from the population. Why do we choose a sample? Well, that's our goals in choosing a sample is to make it an accurate representation. But the reasons why we choose a sample, the number one reason for doing most anything in this world these days, money, yeah. Cost. The cost of gathering information from every member of that population could be prohibitive. Now, I know phone bills aren't what they used to be. It used to be you got charged per call, and that's not necessarily true anymore. But you still have the labor of having people call them or the cost of sending out paper surveys. and getting them returned to you. The second one is time. Depending on how many voters are in that district, it could take a long time to contact every one of them. Now, I usually use the example of a presidential election. Well, that's nearly impossible. There are about 120 million registered voters in the United States. Contacting 120 million people and getting information from them is very difficult to do. It's costly, it's very time consuming. The third reason is identifying the population. How many people here have missed voting in an election? I have. I can admit to it. Most people have. There are some people that don't know right up until the morning of the election whether they're going to go vote or not. So to identify who's actually going to vote and who's not, it can be almost impossible to identify everybody that's in that population. And in other populations, the same type of thing. There might be overlaps between populations or blurry lines, fuzzy lines in between different groups. The fourth reason, I'm going to have to discuss this one a little bit, is changes over time. I'm sure you guys recall from the presidential election just a couple of months ago, it seems like every day there's a new story out, and half the time it's a new scandal. Oh, this person said this to upset a whole bunch of people, or this person's accused of this new scandal, or whatever. You have a small time window. Ideally, you'd gather that information instantaneously. You get information from everybody that you decided to sample, or every item in your sample, all at one instant. It's a snapshot. We're looking for a snapshot of that population, that sample. If you take too long, if you're trying to get information from too large of a sample, it's going to take time to get that information. If you take too long to gather that information, people that you've already gathered information from may have changed their mind, or the circumstances under which you gather that information may have changed. If I start today, let's go back to the election. We're not going to choose sides, but the Trump versus Hillary election here. And let's say that I start today, and today the reality is a small majority of the people are in favor of voting for Trump. So I start surveying people today, and I'm getting a majority of them are saying they're going to vote for Trump. Well, then tonight on the evening news, the news comes out with something really stupid that he said today. And tomorrow I'm surveying people. Well, I'm surveying them under different circumstances. Now I'm getting a majority are saying they're going to vote for Hillary because they're mad about what was said last night. Well, the people that I surveyed yesterday, a portion of them may have changed their mind based on that. But I'm not going to go back and get that information from them. So I'm taking information under two different conditions. You have to get that information in a small enough period of time that things haven't changed. Does that make sense?
Yeah.
I'm just going to say logistics. Basically impossible. Even the people that you, or the items that you choose to be in the sample, sometimes it's not possible to gather information from them. Some people won't return a mailed survey. Some people won't talk to you on the phone. Some people, you corner them in the mall, they're not going to talk to you. There are certain elements in each population that just aren't going to give up that information. So you're not going to be able to get that information. Every 10 years, the United States government tries to do a census. A census is an attempt to gather information from every element in the population. So for the United States, that's every person that lives in the United States they're trying to gather information from. They're never successful because there are always some people that are just going to flat out refuse. Now, a lot of people don't realize it, but in the United States, it actually is a federal crime not to respond to the census. They don't prosecute people over it, but they go through great lengths. They'll spend 2 or 3 years. They should go to the homes, last known addresses of people who haven't responded. They go through great lengths to try to gather that data, but they have never successfully gathered information from every man, woman, and child in the United States. It has never happened. The last one hopefully doesn't apply to people. And I'm just the best way I can describe it is destructive testing. This applies more on the manufacturing or industrial side of things. The example I use here is, okay, let's say you're working quality control for a manufacturer, and you have a part that needs to be able to withstand a certain amount of force. So it needs to have a minimum strength. How are you going to test that? Well, you're going to take a part off of the assembly line and you're going to put it in some sort of a tester. Let's say you got a machine that's going to stretch it. It's going to pull on it. So you put that part in there and you let the machine stretch it until it breaks to see how strong it is. Because a lot of people say, well, why don't you just apply the amount of force that it needs to be able to hold? Well, that doesn't work because sometimes, you get different angles or extreme conditions, you get a little bit more. It has to be able to hold a certain percentage more force than what it's designed to in order to be considered adequate. So generally, they just stretch it until it breaks, and they read what force it was able to withstand before it broke. So now this part is broken. Obviously, you can't sell it. So if you tested every part that came off the assembly line, there wouldn't be anything left to sell. So that's another reason for taking a random sample. If your testing process is destructive, you can't test everything. So we mentioned the word census. A census is an attempt to gather information from a population. Unless you have a very, very small population, a census is seldom successful. A parameter is a piece of information that describes the population. Now, this is one that is often confused, so let me expand on this a little bit. I am not talking about saying, oh, the population consists of men and women between the ages of 18 and 67, or whatever that is. That's describing the population itself. What we want to describe is a variable of interest. In other words, what we want to learn, or what we are trying to learn. So if we are trying to learn about who's going to win that next election, how voters are going to vote in that next election, a parameter would be a statement saying, based on our information, we believe about 60% of the voters are going to vote in favor of this new ordinance. That's a parameter. It's a statement about the population based on what it is we are studying. So it's not saying, we surveyed, the population consists of people between the age of 18 and whatever. It's not describing the population that way. It's describing it about what we are studying. Well, then next we have a survey. A survey is the equivalent of a census. It is an attempt to gather information from a sample or about a sample. A statistic nice to define the word that we're learning about, right? A statistic is then that piece of information describing the sample then. And again, it has to be related to that variable of interest. So we might state "63% of people surveyed indicate they will vote in favor of," we're just going to say ordinance A, just going to say A. Or we might say that we conclude that about 60% of voters will vote in favor of ordinance A, or item A. Which one of these is a parameter? The second one, because we are stating we conclude that about 60% of voters, of all voters, that's making a statement about the population, and it's related to our variable of interest, of the results of how they're going to vote on this item. Now, it may or may not be true, depending on how good our sample was, but it is a statement about the population. So the other one is a statistic, because it is making a statement about that survey. And it says right in there, 63% of people surveyed indicate they're going to vote for it. Generally, a statistic is more exact because we're just making that exact statement about our sample. The parameter is usually a little bit more generalized, about 60% or at least 60%, sometimes it'd be stated, because we're taking the information from that survey and we're now generalizing it about, applying it to the whole sample. There are a lot of potential pitfalls in using samples to gather information. There is a good chance, if you're not very careful, of something called sampling bias. And what that is, the sample results do not accurately reflect the population. So let's say we did this survey, and in our survey, 63% of the people said they were going to vote in favor of this ordinance. The election comes along, and only 30% of people vote in favor of that ordinance. Obviously, our sample was off. So that sampling bias is the difference between the results of your sample and the real value in the population. So the whole point of taking samples, good samples, is to limit sampling bias. Notice I didn't say eliminate, because there's no way the only way you eliminate sampling bias is if your sample exactly reflects the population, and that's never going to happen. But let's say that this ordinance A that we're talking about has something to do with funding for the local schools. Well, if I show up at a high school football game and I survey people at the football game, a good chance that those people at that football game have a connection to the school. A good chance that they probably have a good feeling about the school. So it wouldn't surprise me that a high portion of that group are in favor of an ordinance that favors the school. Whereas if I go, I don't know, if I go somewhere that has a group of people that don't have any kids in the school and have no connection with the school, there's a good chance that they don't care about the school, and a high portion of them might not be in favor of that item for the school. So you have to be careful that you're not taking your sample in such a way that the way you've chosen your sample will affect the results of the survey, of the data. So there's two things that we do in an effort to take good samples. One, the sample size. If I walk out on the streets and I ask the next two people I see what do they think, one says that they're in favor, one says they're against, I cannot conclude that 50% of the people are in favor of that ordinance. Way too small of a sample. In this class, we're not going to get into a discussion of what is an adequate sample size, because that is a very, very deep discussion. And one of the problems with statistics is not an exact science. Statistics has different schools of thought. And there are many, many different theories out there, many, many different rules that have been proposed, depending on what textbook you're looking at or what statistical expert you're talking to, as to what is the best way to determine the proper sample size. Now, one of them that's commonly accepted is that the sample size be greater than or equal to 30. Now, the abbreviation for sample size is the letter N. So say that N is greater than or equal to 30 at a bare minimum. Now, there are times where you can't get more than 30, and we have special exceptions and special cases for that. We're not going to, like I said, we're not going to get too deep into that conversation. Obviously, if we're dealing with a presidential election, surveying 30 people is not going to be adequate. That's not even getting one person from each state. So we're not going to get into those rules. The second is randomly chosen. You know, I used the example of going to the high school football game and just surveying people at the high school football game. Well, you might say that you walk past somebody and you flip a coin, and if it's heads, you survey them. If it's tails, you don't. That's randomly choosing, right? No. That's using randomness, but it's not randomly choosing. Randomly chosen, a random sample, is defined statistically to be every member of the population has equal chance of being in the sample. So for the example we use, people that aren't at that football game have no chance of being in the sample. So that is not a random sample. So now we're going to look at some processes for randomly choosing. The best process, the best type of sample, is something called a simple random sample. The analogy for a simple random sample, to go back to the pre-technology, is basically putting names in the hat. This could be literally putting the names of everybody that is a registered voter or everybody who will vote in the next election in a hat. Again, there's a problem of defining who is actually in that population. But putting everybody in the population in a hat, whether it's their name or assigning an identification number to them, mixing them all up and then drawing out however many you're going to have in your sample. Now, it's very important that before you start, that you determine the sample size before you select. In all of these, you need to determine what size your sample is going to be before you start selecting a sample. That stops you from just starting to select and getting to a point and say, oh, yeah, that's enough. By predetermining your sample size, it forces you to stay more systematic in how you choose that sample. It sounds like it won't, but there's actually been studies done that show a huge increase in sampling bias if you don't predetermine that. So like I said, names in a hat. Simple random has an added qualification. Not only is it random, not only does every item or element in the population have equal chance of being in it, but every group, every sample of size n, remember n is the size of the sample, the number of items in your sample, has an equal chance of being chosen. Now you might be looking at thinking, well, that seems obvious. If every person has an equal chance, well, every group of that size has a possible chance. Well, we're going to look at some processes where it's not necessarily so. There are samples, some textbooks refer to them as samples of convenience, but there's something called a convenience sample that's much different. So we're going to look at samples that are random, but not simple random. One of them we're going to look at is something called a cluster sample. A cluster sample is actually very, very common if you're going to do door-to-door sampling. Now, door-to-door doesn't necessarily mean you're knocking on somebody's door and asking a survey. In the telecommunications industry, happens a lot where they actually go to houses and test the signal on the outside of the house. Well, if they throw the names of everybody in the city into a hat and draw them out, they're going to be skipping around all over the city testing these signals. So what a cluster sample does is it divides the population into groups. And then randomly selects several groups. So again, back to that telecommunications example. If they have to send out a technician to go to the houses that are selected and go to the box on the outside of the house, pull the cover off, and test the signal level, it would make sense to divide the city up into square blocks, into city blocks. And rather than randomly selecting single houses, they randomly select whole city blocks. So they're going to test this block, and this block, and several others. So when they send a technician out, well, that technician is crawling through the backyards. They can test this house, this house, this house, all the houses that are on that block, and they can test them. They can park their vehicle and go walk down the block and get it done. Then they can go to the next block that's been chosen. Otherwise, it would be really a logistical hazard to have one here, one here, one here, one here, jumping all over the place, in and out of the vehicle, going. It's just a huge expense and a huge hassle. So it makes sense in a lot of cases to choose groups and then get information from that whole group at each time. Now again, that's random because every block in the city has an equal chance of being chosen. But it's not simple random because it's not possible to choose a sample that has one person from each block. Or it's not possible to choose a sample that has this person on that block but not the person next door to him. If you're on that block, you're going to be, your whole block's chosen or not chosen. So it is a random sample, but not a simple random sample. It is still valid. The next one is what we're going to call a stratified sample. In a stratified sample, you still divide the population into groups. But this time, rather than selecting whole groups, you randomly select a specific number from each group. For example, if I want to do an employee satisfaction survey for a manufacturer, I am going to divide my facility into departments. And I'm going to randomly select a certain number of people from each department. Now, for this to be valid, a bigger department, you have to select more people from it. If Department A is twice as big as Department B, you have to select twice as many from that department as the smaller one. But what that means is still every person in that facility has equal chance of being chosen. But it's not possible to choose a sample that selects everybody from one department. The reason for doing this is you want to get a good cross-section. You want to make sure you're gathering information from every group. If I wanted to do a survey on students at WITC, I would most likely divide it up between business students, trade and technical students, law enforcement students, health and human services, from different groups, and then randomly select the appropriate number of people from each of those groups so that I can get information about the students. Again, that's random, but it's not simple random. There's systematic samples. In a systematic sample, you randomly choose a starting point. And then the system goes from there. A good example of this would be in manufacturing. Let's say in a manufacturing setting, you need to test, we're talking about, destructive testing on those parts, strength testing those parts. Let's say you decide you need to test 1 out of every 200 parts produced. Well, what you're going to do then is every morning, you're going to randomly choose a number from 1 to 200. Let's say that on a given morning, you choose 57. So what's going to happen is you're going to choose the 57th part that comes off the line. You're going to take that part and you're going to go test it. Then the 257th part that comes off the line, you're going to go test it. The 457th part that comes off the line, you're going to go test it. You need to test 1 in every 200, so you're going to choose that first one, and then after that, every 200th part gets tested. Does that make sense? So it's still random. Every part has a 1 in 200 chance of being selected. But it's not simple random because it's not possible to get 2 parts within that first 200. The final type of survey the type of sample that we're going to discuss is called a convenience sample. I'm bringing this sample up only as a warning. A convenience sample is you take what's easy to get. So it might be, I walk out the door and I survey, if I need to get 200 people, I walk out my door and I survey the first 200 people I see. Well, that's convenient. Or I survey 200 of my friends. Again, that's convenient. A convenient sample is just taking information the easiest way you can get it, or a way that's easy for you to get it, and that is usually not good, well, almost never good. Now, there's another thing I'm going to actually throw out here that's a problem with almost every type of sample that involves people. A self-selected sample isn't necessarily a type of choosing the sample, but it's a problem you have when you're going to gather information from people. It's because people might refuse to respond. If I want to ask, if I want to figure out what is the average income of students at WITC while they're going to school, well, some students might be very touchy about giving out that information. You can't force them to respond. The biggest issue with self-selected samples is when you do mailing surveys. If you mail out a survey, generally you get between a 20 and 30% response rate. So if you need 200 responses, you're going to send out at least 700 to 800 surveys to get those 200 responses. Generally, think about it. If you get a survey in the mail and it's about a topic that you really don't care about, or a topic that you're really against, yeah, exactly, it's going in the garbage. If it's something you really care about, you're going to take the time to respond and send it back in. So the self-selected samples generally are going to be skewed in favor of whatever topic it is. When I was in college, I actually did a study, a project where we sent out political surveys, and we got permission from the Wisconsin Democratic and Wisconsin Republican parties. They actually gave us 500 envelopes from each party. So we sent out identical surveys. All they had was a little symbol at the bottom of the page so I could identify what envelope it was sent out in. And it was sent out, 500 of them were sent out in envelopes that said from Wisconsin Republican Party. 500 were sent out in envelopes that said from your Wisconsin Democratic Party. Well, guess what? First of all, out of each of 500, we got about 100 to 120 back. The ones that went out in the envelope for Wisconsin Republican Party came back with much more conservative results to the political questions. Because if you're a liberal person, if you're a Democrat, if you're associated with the Democratic Party and you get a letter from the Wisconsin Republican Party, it's not getting opened. Most of the time it's going in the garbage. And the same in the other direction. So that is a huge problem. Even if you walk up to someone or knock on their door, there's always that option of refusing to participate. Okay.
What if you get false information back?
There is the other thing. There's always that person out there that realizes what you're doing and decides they're going to mess with you. Yeah, that's there's that danger. When you deal with people. That's why my statistics work was usually in manufacturing, where I'm dealing with parts that they do what I want them to. Okay, so we'll talk about a variable. A variable is actually the specific thing that we are gathering information about. When we are doing this, we are asking a question. So that question might be, are you going to vote for this bill or not? The question might be, is this part meeting its minimum strength requirement or not? The variable is the answer to that question. So maybe the question is simply, do you own a car? So your answer is yes, I do, or no, I don't. That's the variable. That variable can be categorical, or sometimes called qualitative. I prefer the term categorical because if that variable is categorical, the answer puts you into a category. Yes, I own a car. You're in the category of people that owns cars. No, I don't. You're in a category of people who don't own cars. Pretty much all yes or no questions are categorical. You're either in the group or you're not in the group. Another example of categorical might be favorite color. Okay, you're going to choose blue. Well, now you're in the group of people that prefer blue or green or whatever. So it's categorical data. Then there is numerical, or sometimes called quantitative data. Of course, in this case, the answer is a number. The reason it's called a quantitative variable is numbers are quantities. The result is a quantity. Qualitative, the result is a quality. It gives a quality about you, not a number, not a quantity, but a quality. Again, I think categorical and numerical are a little bit easier to understand. Our numerical data, quantitative data, is divided into two different types. There is what's called discrete. Discrete is counted. Is generally the way to describe it. If I ask you, no, I'm not asking you, do you own a car or not? That would be qualitative or categorical. But if I ask you, how many cars do you own? And you answer, 0, 1, 2, 3, 4, that is a discrete variable because you are counting that. Continuous. A continuous numerical variable is measured. Your height is a continuous variable because you're going to measure your height. The technical definition of continuous is no matter how close together two numbers are, you can always get a number that's in between them. I prefer to go just counted and measured. I mean, there is gray area between them no matter how you define them. One of them is time. Well, is time continuous or discrete? People say, well, you can count seconds. Yeah, but you can go down to a tenth of a second, a hundredth of a second, or a thousandth of a second. Technically, time is continuous because you can find times that are in between, unless you define it to be how many seconds did this take. Well, then you are counting seconds. So that can be discrete. Money. A lot of people say, well, money is continuous because you go from $0 on up to however much. But we don't ever count money in less than penny increments. So it could be considered discrete because you can count the number of cents that you have. So there are gray areas in there. It's not necessarily, black and white. Okay, that is time for our break. So let's go ahead and take a break. We're going to come back and we're going to start digging into some of the numbers.